Before I begin with my distinguished panel members, I would like to give you a quick overview of the Alternative Fuels Administration at the Prime Minister's office. So today, global dependence on oil is mainly due to the transportation sector. And this sector is strongly growing, massively growing, as we see it. Now, the problem is that oil is a monopoly. It's a monopoly because it's an only source of energy we have for transportation. Not only that, but it also has negative geopolitical effects, environmental effects, as well as economical effects. With that recognition, the government of Israel initiated a national program for the reduction of oil dependency. Our mission at the Prime Minister's office at the Alternative Fuels Administration is to serve as a catalyst for the reduction of global dependence on oil by positioning Israel as a center of knowledge, research, and implementations in the field of oil alternatives and smart transportation. We want to make Israel a better site. We want to make Israel a test bed in which, together with local technologies, we would like to attract partners throughout the world. Electric mobility will be one of the major challenges that we will have to face in the near future. Electric mobility is actually a holistic approach to urban mobility and sustainable development. Implementation of electric transportation in Israel will be, or we would like it to be, both in the urban areas and in intercities. The different technologies some you'll be hearing about in the panel include electric buses with supercapacitors, personal mobility solution, mainly in urban areas, mass transit solutions, and electric vehicles, of course, and infrastructures. One of the major challenges that electric transportation needs to overcome is the energy storage problem. And another issue is the fear of running out of power, what is called range anxiety. My first speaker from Nation E, Idan Edri, will give a presentation about Nation E.
Hello, my name is Idan. I'm the CIO of Nation E. I want to believe that everybody knows who is Nation E because we are all on the stripes and on your bags, and we have a nice electric cars running. We call it, like a lot of people call it here, the frog, running in the lobby of the boutique hotel. But we are here not just to show concept. We are here to show products. Nation E is one of the only companies that today can present a shelf product for electric vehicle in general and for energy storage specifically. I will start with our flag product that we call the Angel system. 5 years ago, we started the research and development for creating the first electric fast charging system. Our president of the company decided that the problem of electric vehicle will be always the psychological barrier of the range. And we see what happened today with the electric vehicle world, that practically the battery switching system is still a problem psychology-wise, that when you buy the electric vehicle, you don't know what happened if you're gonna get stuck. Because it doesn't make sense that you're running on an electric vehicle, full green, running on a Windows platform, and you got stuck and you have a tow truck from 1970 to come to pick you up. It doesn't make sense. And this truck's running on oil, gas. When we came to this approach, we decided we need to build a system that will be flexible, with weight reduction, with the right recycle life, with the cycle life, to make it fully green and to give a full solution, green solution for electric vehicle. And this is what you see here is the Angel system, one of our product. You can see that the system is divided into two main platforms. The first one, when you see here, this is the software and the hardware components. This is where the brain is. We have the capability today to connect to any existing electric vehicle in the world if it's Better Place, if it's the Nissan, if it's Toyota, Renault, DeVault, all of these cars running on protocols of communication. And on this system, we have all the protocol of communication to come to the car, connect the plug, and charge the vehicle. There is two types of charging, actually three, but two main types. One is a single charging, which is a low, slow one, and the other one is fast charging. We fit both. The only car right now that we can fast charge based on the Shademo protocol, which is the fast charging right now, is the Mitsubishi i-MiEV, and now soon we're going to have the Nissan. When I'm talking about fast charging, I'm talking about less than 15 minutes. You have 80% of battery to continue to run. So imagine what it's going to do basically to the customer who's buying the electric vehicle. He knows that if he got stuck, this system, which located on the back of AAA service car, is coming to him, and less than 15 minutes release him with 80% battery. This is what we call the trigger for electric vehicle to be bought and to push this system forward. But when we say electric vehicle, we're not talking about only electric vehicle. We're talking about buses to make the clean city, all the smart city that's running right now for energy point of view. This system is connected to a network. I can remote this system via TCP/IP network. The same way that you can connect your router in the house, I can connect to the system remotely and to see what's the situation of my battery, what is the status of charging, how many vehicles I charge. It's a platform that I can integrate with a smart city infrastructure or any control center that wants to buy this system. One of the models that we're building right now with smart cities, and it's going to happen here in Israel, is that we're going to have 4 or 5 systems like this located in the City Hall control center. And this system, since it's not delivering energy only for electric vehicle, but also for backing up infrastructure. And I will give the simple example. If you have a construction site in the city, in the construction site you cannot work on generators at night. It's making noise, it's making pollution, people complaining. You cannot work. With this system, when you have 30, 40, 50, 100 kilowatt in your backlot, you can work at night because it's sound silence. You don't smell, you don't feel, you don't hear. And whoever doesn't believe me, you can see it here. It's located in the Harrods Boutique. You can go touch and feel the system. And you can work at night at the same exactly as the generator work, only in this specific system. It's on software, touchscreen, very elegant, very clean, full green solution, and you can work as nothing happened. If you need to transfer the system from one place to another, no problem. It's mobile. We call it the mobile energy. This is one of the products that we are developing and basically selling today. One of the most important things that we would like to mention is, in order to close the green cycle, unlike a lot of companies in the world that give the solution, but forget that for this solution you need to put the green cycle, this system, ladies and gentlemen, can be charged from renewable, from wind, from solar, for any renewable energy source, and to close the green cycle. In one hand, I'm charging it from renewables, and I'm delivering the energy to electric vehicle. This in order to provide that the system will be relay only from charging from the grid, because we would like to, again, to put the stamp of a green solution. As you can see, 5 years is a lot of time to develop this system because most of the brain is on the software. What you see on your screen in front of you is the software of the system, which is very high, very high profile and written on a lot of languages. And it was very hard to learn all type of batteries and standards that existing today of electric vehicle, how to charge, how to communicate. And this is the secret of Nation E today, that we know how to communicate with each type of battery existing in electric vehicle. Nevertheless, to create one platform that can charge in one hand, can be monitored in the other hand, and distribute in the third. And this is the flag of Nation E. We are managing energy, we're distributing energy, and we're storing energy. One of the products that I'm not going to show here because we're talking about electric vehicle, but it's important for me to mention, we just finished a panel on smart cities. And everybody's talking about smart cities, how important to have a smart camera system and how important to have smart remote control for the police department, for fire department. But everybody forget what happened if there's no energy. Once you have power outage, all those beautiful systems is going down and you're losing control. One of the flags of nation needed for smart cities concept and for smart cities products, we're giving a platform that we call it smart energy for smart cities. We're taking any existing source of energy existing in the city, also generators, fuel cell, UPS system, battery packs, all existing energy source that spread in the city. Via our gateway, we're communicated with all the sources, making one platform, and you have one gateway of energy backbone. As I said, this has nothing to do for electric transportation, what we're talking right now, but it helped to push the electric transportation because every vehicle carry amount of energy inside it. If I can communicate with this amount of energy and deliver it to the grid or backup infrastructure of the city, I can create another layer of backbone for energy. Thank you.
Thanks, Idan. We'll have questions at the end. Personal rapid transportation is actually it's a mode featuring small automated vehicles running on specially built guideways. Some of you might have seen the news item on Channel 22 a couple of weeks ago in which Jerry Sanders, CEO of SkyTrain, stated that the first public experiment of such a transportation will be here in Israel, and I want to welcome him to talk about that. Jerry Sanders.
Thanks. I'm happy to be here, and I am delighted that you all made the trek down here. I am here to talk about SkyTran. SkyTran is what we call a NASA Space Act company. That means that we have, among very few other companies, an agreement with NASA, pursuant to which NASA provides us with technology support, software, hardware, material, and logistics. As a consequence, we're based in the NASA Ames Research Center in Mountain View, California. We approach the issue of energy and petrol fuels through the side of congestion, and that's why congestion is made larger here. My PowerPoint isn't up. Is my PowerPoint up? Sorry, let me go back there. You missed some good stuff. Okay, there we go. So we approach the issue of energy usage through the congestion side, because congestion is a worldwide problem. And aside from the folks like you who perhaps are more concerned with energy than the rest of the population, we don't believe that when someone wakes up in the morning, she necessarily thinks, oh, you know, I'm going to pollute the earth on my way to work today. What she's thinking is, oh, I'm going to sit in traffic for 2 hours on my work today, on my way to work. And our approach is, if we can address the congestion, if we can really approach the Achilles heel of transportation where people really feel the pain, and that's in the traffic. It's not in the notion that somewhere in their back of the mind they're polluting the earth. If we can approach that, then of course the byproduct is we'll reduce congestion. And that's how we came to SkyTran. That's the philosophy behind SkyTran. It's a fast, very fast elevated transportation system. It is exclusively yours. You don't have to share it with others. And when we look to why only 3% of the population in the United States uses public transportation, typically it's because people don't want to follow schedules. They don't want to share and be pushed in the vehicle. They want to not have to stop at other people's stations. And they want to be able to get on the system whenever it's available to them, not to other people. And therefore, our solution is not to build bigger pipes, if you will, for bigger, massive transportation systems, but to build small, personalized vehicles in a very low-cost network. We all know public transportation alternatives, as I mentioned, are not in use. Even those that are supposedly very fast, they're very fast when they're moving, but when they're stopped at a station, they're going 0 miles per hour. So even a bullet train that is supposedly going 400 kilometers an hour is going 0 kilometers an hour when you're waiting for it to arrive, when you're at the station, not on your destination. It is polluting. They're vulnerable in not only in accidents, but of course in attractions to terrorist acts. They require massive infrastructure. They're very expensive to build. I think some of you know that the Jerusalem Light Rail costs somewhere between 120 to 160 million a kilometer, which is really mind-boggling when you think of it. SkyTran really comes at this question by replacing the roads and the heavy concrete infrastructures, which themselves cause great pollution, with an elevated aluminum guideway. We replace the polluting combustion engine with a linear electric motor, and we replace all tires, wheels, mechanical moving parts, because we are an elevated system. We move on a cushion of air by virtue of a unique passive magnetic levitation system, which enables us to fly with a magnetic wing, and therefore all of our propulsion effort is greatly reduced compared to any other system. So just by way of example, we use approximately 70 watt-hours per mile per person. And if you were to compare that to a car, that's about 1/20th of what a car uses and about 1/3 of what an electric car uses. The system, as I said, is dynamic mobility in that you never stop at someone else's station, because there are off-ramps and on-ramps, just like a freeway. The system is on demand. It's just like a taxi stand. You show up, the system is run on a neural network, so it knows at what time of day where vehicles are required, and it automatically sends vehicles only to those locations. You can also call a vehicle on your smartphone. You don't have to follow schedules, so you show up, you get on the vehicle, and you go to your destination. Because the system is so lightweight and the vehicle's so small, they can be in virtually any what's called a Class A building. Any modern building can tolerate the systems as a station, and no retrofit is required. Vehicles can go on top of buildings, on sidewalks. It doesn't need to follow a traditional grid. We use renewable clean energy. Of course, we're an electric vehicle. And I think when comparing to regular public transportation, it's important to recall that regular public transportation is moving all day long according to a schedule, regardless whether there are people in the vehicle or not. SkyTran doesn't move unless there's someone in the vehicle. So in that regard, it's also very efficient. SkyTran systems allow cleaner urban environments because less parking spots are required, and with a very simple system of poles and guideway, we can canvass neighborhoods. I'm not going to spend a lot of time on these energy slides, but please contact me and I'll be glad to share this PowerPoint with you. But I think the bottom line is, if you look at the watt-hours per mile per passenger, you can see that SkyTran dramatically is ahead. Again, CO2 comparisons per passenger per kilometer, dramatically low emissions. The charts reflect on trains and buses and gas two variables depending on how many passengers are in the vehicle. But even if one looks to full capacity in the vehicle, one sees that SkyTran is still more efficient than any of these. Again, looking at sustainability challenges, SkyTran is the only one that addresses all four of the big parameters: greenhouse gases, land use, cost of system, and contribution to congestion. The system is very inexpensive, and that's because, in contrast to virtually every other public transportation system, SkyTran is built like Lego. It's made in a factory, and then it's carted off to the site and assembled on site. Each piece of our Lego comes with a barcode, and so the assembly team just looks at the barcode and knows where to place that particular component. So again, comparing costs, these are not the highest costs. These are actually median costs. One can see that SkyTran comes in very nicely at cost per mile of around $9 million, around $6 million a kilometer. As I said, light rail costs are anywhere north of $100 million a mile. The system is very safe. We have great redundancies in the guideway and network safety systems. It's designed like an aircraft because it really is an aircraft. And We have a very sophisticated software system, as I mentioned. It's a neural network and is constantly refining itself to allow vehicle redundancy where required most. Although a small company, we're backed by giants, including NASA, SAPA, big aluminum company, Moog is the large engineering firm, IDEO, some of you may know, they're really the people behind the smartphones. Magnus Steyr is a vehicle designer. So we have a good team of people. Here in Israel, Mayor Feyerberg of Netanya has given us a first phase in East Netanya, where she is hoping that eventually we'll roll this out and be able to compare the two sides of Netanya, east and west, back together again. So we've designed a 45-kilometer system that we intend to implement after we do this first 3.5, 4-kilometer system. And Mayor Huldei has just recently given us the invitation and approvals to build a system from Atidim, Ramat HaChayal, through the Yarkon Park, through the University of Tel Aviv train station to the port of Tel Aviv. And we have some projects going on outside of Israel. Kottayam, India, in the state of Kerala is one, and another one is in Malacca, Malaysia. And delighted to take any questions later or online, and we hope to see you in the vehicle. Thanks.
Let's go to the United States for a second. The U.S. Department of Energy Clean Cities Coalition, Clean Cities Program, has set its primary goal to reduce petroleum use in the United States by 2.5 billion gallons by the year of 2020. The next speaker, Meital Stavinsky, is a board member of the City Coalition, will give an overview of the Clean City mechanism and if a similar model could be implemented here in Israel. Meital.
So, good afternoon. As Anat mentioned, Clean Cities is the U.S. Department of Energy flagship alternative transportation deployment initiative. It's sponsored by the DOE. As I figure out how this. Okay. To date, Clean Cities has saved more than 3 billion gallons of petroleum since its inception in 1993. The DOE's Vehicle Technologies Program develops and deploys efficient and environmentally friendly highway transportation technologies that will enable the U.S. to use less petroleum. To date, we have more than 10,400 stakeholders contributing to the Clean Cities goals and accomplishments through participation in nearly 100 Clean Cities coalition across the U.S. This is really an opportunity for public-private partnerships because each Clean Cities in each of the cities where it has a chapter brings together the utilities, the local states government, national laboratories, private companies, and all together working to achieve this very important goal. So the major goals of the Clean Cities is to adopt alternative and renewable fuels, idle reduction measures, and fuel economy improvements, and new transportation technologies as they emerge. And this is where I believe that Israeli companies may have a lot to contribute within the scheme of the Clean Cities Coalition. So the major goal of the Clean Cities is to reduce U.S. reliance on petroleum in transportation by enabling local coalitions of public and private sector stakeholders committed to reducing petroleum use, identifying funding and financial opportunities to support those projects, which is a very important element, reaching out to large fleets that operate in multiple states and help them reduce petroleum use, providing technical assistance, and analyzing data and data collection, which is also a very important tool. And finally, address technology barriers and help overcome those barriers. The national mission of the Clean Cities is to advance the energy, economy, and environmental security of the U.S. by supporting local actions to reduce petroleum use in transportation. As we all know, the U.S. relies heavily currently on foreign oils to power its transportation sector. In 2010, the U.S. imported about 49% of its petroleum. And because transportation accounts for about 71% of U.S. petroleum consumption, reducing U.S. dependence on petroleum-based fuels is crucial. In 2009, the Clean Cities program was awarded $300 million pursuant to the Recovery Act. The funding were used towards state and local governments and transit authorities' expansion of clean, sustainable vehicle and fueling infrastructure necessary to support the organization. The funding were used for alternative fuels or advanced vehicle projects and required, in most cases, 50% participation. And through those funding back in 2009, there was a huge adoption and advancement of various electric vehicle charging and infrastructure in the US, and as well other alternative fuels resources, and finally raising public awareness to the importance of the alternative fuels. I want to touch now on some of the current projects. There are projects that have been already in the process through Clean Cities, and there are more projects to come, and I encourage you to follow that as this is for companies that are looking to work in the US, that could be an interesting place to look at opportunities. So the EV planning grant, in 2011, the DOE awarded $8.5 million to 16 electric vehicle community readiness projects supporting activity in 24 states, including the District of Columbia. Through the Community Readiness and Planning for Plugging an Electric Vehicle and Charging Infrastructure Award, local public-private partnerships are collaborating to adopt EV deployment strategies. The awardees range from localities that have extensive already EV planning experience, but also localities that don't have that and looking to develop this experience. And depending on the needs of each local county, state, the activities include updating permitting process, revising city codes when needed, training emergency personnel, educating the public, and developing incentives. And once submitted, which is expected very soon in December, awardees are creating a public plan that, upon completion, will be available for all other stakeholders in all other states, because as you can see, only 16 were awarded, but it will be open to the whole US for all the 100 coalitions. Florida, for example, was one of the awardees and has a 7-county regional planning effort with the goal of removing barriers for EV and EVSE deployment in Southeast Florida. And currently there are 5 teams focusing on fleet adaptation, policies and permitting, infrastructure development, education and outreach, and a specific demonstration project which is across US 1 corridor in Florida. Another award that was through the DOE Graduate Automotive Technology Education Initiative was $6.4 million to support 7 centers of excellence at American College. Again, our idea focusing on critical automotive technologies areas, and that's a very important tool as well. When we're talking electric vehicle infrastructure, according to Pike Research, Annual commercial EVSE sales will rise from less than 95,000 in 2012 to 1.4 million units in 2020. And the US is expected to specifically to rise to 23,000 units in 2020. The DOE and the administration, the Obama administration, has a very specific focus right now when it comes to electric vehicles, to focus on charging at work and charging at multifamily dwellings, the public charging. This whole infrastructure and all that it entails, in that scam, the Clean City is already playing an important role with the planning, but the next phase will be the deployment, and the Clean Cities will be very active there. An award that was just this month, early this month, was announced by the DOE, is for the implementation initiative to advance alternative fuel markets. There were 20 Clean Cities chapters that were awarded $1.1 million to help states and local government cut red tape and develop the infrastructure, training, and regional planning to help meet the demand for alternative fuel cars and trucks that can run on electricity, natural gas, and propane. For example, the city of Austin, Texas, was selected for an award of $500,000 to streamline infrastructure procurement, conduct electric and natural gas vehicle safety training, and host workshops to help fleet users. Kansas City, Missouri will leverage a federal investment and approximately $850,000 to support training programs for officials and fleet managers, and will also establish a green fleet technical assistance and certification program for the region. And another project, it's again through the Clean Cities, it's partnership to drive sustainable national parks. And as I'm sure, I hope you visited some national parks in the US. They're huge and beautiful and have a great traffic of visitors. So in June 2012, the DOE, the National Park Service, jointly announced that 5 national parks around the US will deploy fuel-efficient and alternative fuel vehicles as part of an expanded partnership of the Clean Cities, DOE, and national parks. The DOE is providing $1.1 million for this specific project. And increasing the efficiency and alternative fuels of vehicle fleets at 3 parks is impacting just those 3 parks over 32 million visitors annually. With a goal of saving $250,000 fuel equivalent to nearly 16,000 gallons of gasoline and about 82 tons of greenhouse gases. And the planned project will showcase alternative fuels, advanced technology vehicles, ways to reduce vehicle idling, and other action drivers can take to save fuel. And so one of the parks, an example for one of the parks that was awarded is the Golden Gate National Recreation Area in California. And what they're planning to do together with the San Francisco Clean Cities is install 5 electric vehicle charging stations there and provide the park employees with 5 electric vehicles. They also plan to upgrade its heavy-duty maintenance equipment to run on biodiesel and fuel and infrastructure to support it. This specific project is a result of a pilot project that was completed, among others, in Yellowstone National Park. And over there, as well, there's reaching to 6.5 million visitors each year. So again, the Clean Cities demonstrate the importance of public-private partnerships and how together all those, the utilities, the local municipalities and the companies can work together to overcome market barriers and to create projects and to find to get funding for those projects. And I know those projects, there are some developments both in Tel Aviv and Netanya on the way, but it might be something to consider to adopt elsewhere in Israel and follow the same model and maybe create even a better one, as Israeli always do.
Thanks, Meital. City cars. The concept of electric city cars is actually small cars, primarily for urban area. They might be a perfect answer for the urban stress and pollution. But the problem is that they are capable of short driving distances. However, the Electrification Coalition in the United States actually said that 90% of US vehicle trips are less than 30 miles, equals to 50 kilometers. And in Israel, it's even less. It's 30 kilometers. It was just published that the Tel Aviv municipality is currently in discussion for implementation of citywide electric car network based on the sharing and the renting model. I would like to invite Sharon Leventhal, president of Afikim EV, to give us some insights on electric city cars. Thanks.
Okay. I can make it very short, as we are a little bit behind schedule, saying that city car are good for your health, and that's it. But it's not good enough. I would start by debating some of the facts, as you know them, about city cars. Or I just came back from the US, as they say, true facts, as you know them, about electric cars. We produce electric vehicles already 35 years now. And 95% of our production are going to mobility persons, which already adopt the electric cars or electric vehicles now for almost 40 years. But since we are doing that, the last 35 years, the development of electric transportation, electric power units, electric storage, electric management didn't change much if we compare it to other industries. And the barrier is still remaining the range of family car, mainly. So we consider to take it to an area which range won't be a problem. And when we searched it, we found out that in Israel, most of the cars in city doesn't do more than 30 kilometers a day in the city, while a very simple electric car is doing 3 times more than that. The other thing is the development of hybrid cars, which happened the last 10 years, I think affected the market of pure electric cars. And economically, there is a very slight advantage of buying a pure electric car, which there are a lot of disadvantages for users using electric car compared to a hybrid car. But it's not the same in the city, because again, in the city, we can provide a car which drive 24 hours without charging, or full day without charging. The other thing for us as a small company, we didn't want to go into the big dogs market like Toyota or Honda. So we looked for a niche market. But at the same time, we found out that companies like Black & Decker is also searching for the same market. So we went from one huge company to another huge company. But still, it's a niche market. And just to give you an insight, what is electric car or electric city car? We're talking about cars that will move under a different regulation than the car as you know them. At the US, I think they call it street legal, if I remember, which you don't need actually to have tested yearly the car. And the regulation is much easier. You don't need all these safety features in the car, like airbags and so on. Just give you another example of electric car. They're all already driving on roads. This is much more fashionable, Italian one. This is very latest car that is now launched on streets. But I would say that when we try to push this electric city car, or in some countries they call it quadricycles, we find that there is a misunderstanding between electric car and mini cars or urban cars, which people say, we have mini car, it's a very small car, which can move everywhere, but it's not the same as electric cars or electric city car, as we call them. They are only to move in cities. They can't, under regulation, move outside the city, between cities. While mini cars or urban cars or compact car, all of them can actually they are driving under the regulation of normal cars. For instance, Fiat 500, which is a very popular car nowadays, it's not a city car. It's just a small car. It's a mini compact car, but it's not a city car as we call it. When the major difference between city car, electric city car, and the mini car is the sizes. We talk about a car that its length is less than 2 meters. If you take the smallest car today, like Fiat 500 and others, they are all more than 3,000 millimeters or 3 meters. The other thing is that we limit the city car only for 2 passengers. We found out that 80% of the cars are driving only with 1 passenger, the driver. So 2 passengers will be good enough for 80% of the users in the city. The other thing is, of course, it has to be purely electrical, and of course, plug-in car could be charged everywhere. One of the cars that is very popular, and it's, I would say, almost there, is Smart. You all know it. Smart is giving, I think, 90% of what electric city car is needed. It's 2.5 meter, so it's almost there. They have a purely electrical car. You can see the advantage of parking with with city car. A city car, because of its size, will reduce the parking spots by 50%, or at the same parking spot you can condense twice as much. But the disadvantage of Smart is the prices. When we talk about city cars, we talk about cars that will cost between 6,000 to 10,000 euro for end users. So what is the advantage of city car? First, of course, is the price. It's a very cheap car. Second, it's, like they said here, it's clean, but we don't call it green because we do not control the source of energy. It can come from renewable energy, or it can come from polluted energy. The advantage for us, for a city car, it's by distributing the pollution from the center of the city to other locations. And of course, the biggest advantage is that it's moving at the same speed as a normal car, even though we limit it to 50 kilometers per hour. But it's very cheap charging. Fully charged a day, we talk in Israel, for only a few shekels a day. So if you compare it to fuel, it's of course a big difference. Again, there is no regulation in Israel for city cars. At the moment, city cars, as we do it, are sold only overseas. But the advantage of city car mainly is reducing the traffic in cities. or the condensed traffic in cities. Of course, we don't need, at the moment, there is lack of parking spaces everywhere. Every major city you visit, you find that there is not enough parking space. So we can earn, as I said, twice parking spots at the same time as it is now. And distributing pollution is of course a big issue at the moment. That's it. Thank you very much.
I want to take this opportunity to mention two other pilots that will be conducted here in Israel in the coming year in public transportation. One of them, I'll make it short because lunch is actually starting soon, but one of them is Dan hybrid bus. Dan, for those of you that come from abroad, is one of the two major bus companies here in Israel, and it's in Tel Aviv. So when we look at this, first of all, at public transportation, the advantages of it is regular routes, frequent stops, night charging, and it looks like a perfect solution for in the city transportation, and it's a reduction of emissions and noise. Another pilot that will be conducted starting on May this year is 6 hybrid buses in the Haifa area bay. So again, we're looking in the city transportation. And I want to end this panel with giving you this graph. When you look at it, we at Israel have the opportunity, we have the privilege to conduct an experiment of no cars and no transportation for one day. And this experiment is called Yom Kippur. And the graph actually illustrates nitrogen oxides emissions in the city of Tel Aviv, but it's pretty much the same as for other urban areas. And it actually emphasizes the emissions caused by transportation. And with all of the technologies you see and the solutions you see around the graph, I think we can lower the regular emissions to that, maybe getting near the ones that are in during Yom Kippur. Thank you very much. And if there's further questions, each one of my panel members, you can approach him and have a nice lunch.